Welcome, folks. We're going to talk today about finding exact values of trig ratios for angles in radians. This is pretty similar to some stuff that you did in grade 11 with degrees. We're going to be using this skill as part of a lot of other skills. So if you look at this and you think, oh, I know how to do this in degrees already, I'll just do conversion from radians to degrees and it'll be pretty easy. I'd really recommend spending a little bit of time working on this, making sure that you get comfortable with it and that you've practiced, because it's going to make other skills much, much easier and faster if you spend a little bit of time right now. So here's the basic idea. If we think about XY axis and we draw the circle of radius 1, then what we'll see is that we can use this circle, pardon my circle drawing, we can use this circle to get us information about the sine, cosine, and tangent of a particular angle. So in particular, let's say I pick a specific angle. Let's go with pi by 4. You probably recall that in radians, pi is 180 degrees and 2 pi is the full 360 degrees. So pi by 4 turns out is the same thing as 45 degrees. So if we look at the point on the end of the arm of this angle and on the unit circle, so where the arm of this angle touches the unit circle, in other words, at a distance of 1 from the origin, so radius length 1, the x and y coordinates of this point are going to be really useful to us. And the reason for that is that the y-coordinate of this point is simply the length of this side of the triangle, and the x-coordinate of this point is the length of this side of the triangle, and that's because both of them start at 0. So here we go from 0 to here, that's the length. Here we go from 0 on the y up to there, and that gives us the length. Since sine of this angle is opposite over hypotenuse, and the hypotenuse is 1, then the sine value is going to end up just being opposite. And that's because hypotenuse is 1, opposite divided by 1 is just opposite. And the opposite is the length of this side, which, as we said, is just the y value. So this is going to be sine of pi by 4. The adjacent side, well, that's cosine. I guess I should put theta in here. Equals adjacent over hypotenuse. But again, the hypotenuse is 1, so we just get adjacent. And that means that this side length, and its length is the same thing as the x-coordinate of this point, is cosine of the angle. So cosine pi by 4. Okay, so now we just need to figure out what are the actual values of these two things. And for pi by 4, we know that that is 45 degrees, and so we can sub in our values. If you recall, sine of 45 degrees is, hopefully you can remember this, 1 over root 2. Cosine 45 degrees, same thing, 1 over root 2. So what we'd like to do is to take a unit circle. I'm going to draw it a little smaller here. go. And to set out for each of the angles what the value of sine and cosine are, or in other words, what the x and y coordinates of the endpoint are. And from there, to be able to start to memorize what those values are for different radian angles. So by the end of this process, if somebody says to you, what's the value of tan 5 pi by 4, you should be able to figure that out in sort of a 5-second, maybe 10-second time span. If you have to reach for a calculator to get this, or it takes you 30 seconds to a minute to get this, then you're going to run into a lot of trouble on tests. So that's our goal here. The process I'd like you to go through in order to figure this out, I'm going to give you a document that has a unit circle on it, and I'd like you to try for each angle that is a multiple of pi by 6. So that is pi by 6. Sorry, I guess I should say pi by 6 or pi by 4 multiples. So pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, ... all the way up to 11 pi by 6. And you'll notice that many of these are not in lowest terms, right? So 2 pi by 6, that's the same thing as pi by 3. 3 pi by 6, that's the same thing as pi by 2, and so on. So for a lot of these, they can be simplified down, and you'll get something different. And then I'd also like you to add the multiples of pi by 4. Pi by 4, 2 pi by 4, 3 pi by 4, ... all the way up to 7 pi by 4. So going all the way around. So you'll have a bigger drawing. You'll put these angles in with the point. So if I was doing pi by 6 here, I would list pi by 6 after the point, and then I'm going to put in the cosine and sine, which are the x and y coordinates of this point. So pi by 6 is 30 degrees, cosine of 30 degrees. So you can see if you can remember what that is. And then sine of 30 degrees. If you're having trouble remembering these things, you can always use the special triangles. So for pi by 6, we're talking about the equilateral triangle cut in half, 2, 1, root 3. So there's pi by 6, or 30 degrees. Cosine of that is going to be adjacent over hypotenuse, so root 3 over 2. And the sine of that is going to be opposite over hypotenuse, so 1 over 2. So now I have pi by 6. I can see that the cosine is root 3 over 2, the sine is 1 over 2. And if you would like, you can add the tangent to that. Tan pi by 6. What's the easiest way to get it? Well, tangent is sine theta over cos theta, so it's this one divided by this one, in this case 1 over root 3. So please go and fill in all the way around for each of these angles in either of these two lists. The sine, the cosine, the angles measured as radians, and the tangent value. Normally in class we'd spend a couple days setting this up and then playing some games where we're practicing it so that we get good and fast with it. Obviously this year we don't have that option, but please do try to get some facility with this. It will make the rest of our trigonometry work much, much easier and faster for you. If you have any questions, please let me know.